Okay, welcome to Introduction to Java Programming by Y. Daniel Yang, 8th edition. Welcome to Introduction to Java Programming by Y. Daniel Yang, 8th edition. Chapter 3, Selections. Problem number 1. Write a program that solves a quadratic equation. The formula of a quadratic equation is ax squared plus bx plus c equals 0. The program should first compute the discriminant, whose formula is b squared minus 4ac. If the discriminant is positive, the program should display the two roots. If the discriminant is 0, the program should display one root. And if the discriminant is negative, the equation should have no root. The program should prompt the user to input values for A, B, and C to proceed. In the case of two roots, the formulas to compute each root is R1 equal minus B plus the discriminant B squared minus 4AC to the power of 0.5. To the power of 0.5 means we're getting the square root. So like that, we would be getting the square root of the discriminant. So minus b plus the square root of the discriminant divided by 2a. And R2 equal to minus b minus the square root of the discriminant over 2a. So I say again, if the discriminant is positive, the program would display the two roots. If the discriminant is 0, the program would display one root, which is obvious because if the discriminant is 0, then all of this is 0 in R1. And at the same time, all of this is 0 in R2. So R1 would be equal to R2. That's why the program would display only one root. And if the discriminant is negative, the equation should have no root. So let's get started. Okay, now first I'm gonna need the user to input the values of A, B, and C. So with that, I'm gonna import the scanner from java.util.scanner. Start deploying a scanner object. So scanner, name my variable as input equal new scanner system.in. Commented as scanner reference to gather user input. Okay, next I'm gonna need 3 integer variables for A, B, and C. So int A, B, C. Values of A, B, and C given by a user. Next, I'm gonna need the discriminant, so it's gonna be let me set ABC as double instead of integer. And also I'll set a double variable for the discriminant. So discriminant and 2 double variables for the two roots, R1 and R2. So the two roots, the two equation roots. Okay, now I can start. So prompting the user to input the following values of A, B, and C. Enter the values of A, B, and C. After that, I extract these values, starting with A equal to input dot next double, and also for B. Now for B equal input dot next double, and then I extract the value for C, input dot next double, like that. Okay, now I have the values for A, B, and C. Now I can compute the discriminant. So I'll set the discriminant equal to B squared minus 4AC. So B times B, well, let me just fix it, minus 4 times A times C, like that. Okay, now after computing the discriminant value, I can proceed to compute R1 and R2. But first I have to verify whether the discriminant is positive, 0, or negative. So I'm gonna have to implement the if conditions. So I'll just comment here as condition. So if discriminant is more than 0, then start with R1 equal minus B plus discriminant Okay, to be able to get the square root, I'm gonna have to call the class math and use a method called pow, which gets the power of the value powered by the second value. So the value of A in here would be the discriminant followed by the exponent value. So here I'm gonna need it as 0.5. So discriminant exponent 0.5 as if I'm getting the square root of the discriminant. I can also use it here. So instead of B times B, I can use math dot pow. A is B, the value of A is going to be B, and the second value is going to be 2. So B squared. And in here, after getting the square root of the discriminant, now I can divide this by 2 times a. Let me separate these. Alright, now getting a value of R2, so minus B minus math dot pow discriminant exponent 0.5 divided by 2 times a. Alright, now I have these two values. I can now print the equation has two roots. Okay, follow these by an escape character. Escape n for a space break. Root 1 points and print the value of R1. Then another string, another escape n, only that, and root 2 and the value of R2, like that. So this is implemented if that, so this is not implemented, so this is executed if the discriminant is positive. Now, what if the discriminant is 0? So I'll put here else. Let's start a new line. Else if discriminant equal to 0, then I'll just need R1, since R1 is gonna be equal to R2. So let me just copy this, print it here. The discriminant is 0, so I don't need that. Just this. Alright. So print here the equation only has one root. Escape n, root, and print the value of the root. And here I have the value of R1. Next, the last condition is if the discriminant is negative, then I'll just have to put else, no condition, and just print the message that the equation has no root, like that. And at the end of the program, I closed my scanner. Let me comment here, closing the scanner. And as simple as that. Let me just run it once. I don't have to try to test them all. So 2, 5, 6. The equation has no root. Let me try once more. 1, 6, 8, 1, 1, 4, 5, which has no root. Let me check if I have an error just in case. Okay, so I thought of a better way to test our program to make sure that our program has no error. So I'm gonna debug my program and set breakpoints for every variable in order to monitor their values and how they're changing. So set the breakpoints for every variable. I don't need to set breakpoints here. I'll just set the breakpoint in the end. Now, press here to debug. Okay, step over. Application is running. Alright, so now it's prompting me to enter values for A, B, and C. So let me just try and test it. Okay, so the first value has been extracted and assigned to A. Let me go here, step over, B equal 2, C equal 3. Where is C? Here. And here, C equal to 3. Okay, so I got my discriminant minus 8. Now I entered my selection block for the conditions. So discriminant more than 0, false, since discriminant is minus 8. So step over, discriminant minus 8, discriminant equal to 0, false, and the equation has no roots. It should print this here. Let me step over. Yeah, so this worked. Now let me run this again to try setting the discriminant to 0. So if this is the formula for my discriminant, this is the formula for the discriminant. So to set the discriminant to 0, if I set B to 2, I get 2 exponent 2, 4, minus 4 times 1 times 1, 4. So 4 minus 4 would be 0. So that's how I get 0 as my discriminant. Let's try that. So A1, B2, and C1. Step over A1, B2, C1. Here I got my discriminant 0. So discriminant 0, more than 0, false. Okay, equal 0, true. There I compute my root. So the root is minus 1. And finally, the equation only has one root. Root equal minus 1. And in case the discriminant is less than 0, then it will just print the equation has no root. Or we tried that, so let's try that for the discriminant to be positive so that it would display the two roots. So let me rerun this program. Okay, for the discriminant to be positive, I can set B equal to 0, A to minus 1, and C to 1. Okay, let's do that. So A to minus 1, B to 0, and C to 1. A minus 1, B 0, C 1. Discriminant equal 4. Okay, let's try. I got my root 1 minus 1, and root 2, 1. And the equation has two roots, root 1 minus 1, root 2, 1. And that's how we use the debugging method in order to test our programs to make sure that there is no error.